Hi everyone, welcome back. This is Unit 9. This is Lesson 1, and we're starting a new unit on solutions. And what a solution is officially defined as is a homogeneous mixture. Some people say homogeneous. It's the same word. It means homogeneous. What a homogeneous mixture is a uniform mixture. In other words, there is more than one substance. It's a mixture of two or more different things. And in a homogeneous mixture, the particles are evenly distributed. And since the particles are evenly distributed, no matter where you sample that mixture, you'll always get the same stuff, okay? So salt water, Kool-Aid, milk, coffee, tea, those are all homogeneous mixtures. They're all solutions, okay? No matter where you sample them, and I know yours didn't copy well, but it's like this checkerboard idea. No matter where you sample, you're going to get an equal number of, an equal sample of your mixture, okay? They'll all have the same composition because the particles are uniformly distributed, the parts. Whereas in a heterogeneous mixture, there may be a clump, you know, like a clump of one type of particle and then a clump of another type of particle. The particles are not evenly distributed. Okay, we also defined a homogeneous solution or a homogeneous mixture as even though there's, on the macro level, even though there's more than one thing present, it only looks like one thing with your eye. So with Kool-Aid, if you think about Kool-Aid, you have the water, you have the sugar, you have the dyes. So there's more than one thing. Citric acid is in Kool-Aid. There's more than one thing there, but when you look at it, it's like, wow, that's great Kool-Aid. It only looks like one thing. So that's what we mean by homogeneous. It means they have the same properties throughout. The particles are evenly distributed, okay? There are many different types of solutions. You could have a mixture of gases like air. You could have a mixture of solids like brass instruments, okay? But mostly what we're going to talk about are aqueous solutions. We're mostly going to talk about stuff being dissolved in water. Okay? Your blood is a mixture. Talk about relevant. Your blood is not just one thing. Your blood is really made of two major components, which is the plasma and the cells. The plasma, though, is water and proteins and nutrients like hormones. There's electrolytes. And then the cellular components, you have white blood cells, you have red blood cells. White blood cells fight infection. Red blood cells carry oxygen. Platelets allow your blood to clot. So even though your blood only looks like one thing, right? It looks like red and it's kind of scary. It's made of many different things. And so we call that a homogeneous mixture. And that's what solutions are. Solutions have two major components. They have the stuff that you dissolve, and they have the stuff that does the dissolving. And so the stuff that gets dissolved is usually present in a smaller amount, like the sugar in Kool-Aid or the caffeine in coffee or something like that. We call that the solute. Okay, the U is a long U, right? Solute. That is the stuff that gets dissolved. And the stuff that does the dissolving is known as the solvent. It's usually present in the greater amount. And 99% of the time in this class, the solvent that we will use is water. Water is a great solvent because it's polar. It has partial charges that can dissolve a lot of things. Okay? So the solute gets dissolved in the solvent. Okay? So if you have Kool-Aid and you make Kool-Aid, Kool-Aid is the solute and water is the solvent. So two major parts of a solution. Together, they make up the solution. A lot of times I will abbreviate solution, SOLN, just so you know if you see it, because we're going to write it a lot. In this class, we're going to talk mostly about aqueous solutions, AQ, and aqueous is used to describe water solutions. It means dissolved in water. So in aqueous solutions, water is the solvent. Aqueous or liquid solutions have the following properties. Number one, obviously they're homogeneous. Now, I don't know about you, but I have a hard time making my Kool-Aid homogeneous. My Kool-Aid always has floaties. So when we talk about aqueous solutions, you want to assume everything dissolves. And so you can't see it. You want to assume no floaties, okay? You want to be able to make good Kool-Aid. There's nothing worse than when you make Kool-Aid, you get to the bottom and it's got all those little particles in it. That's not what we're talking about. We're talking about good Kool-Aid, where it's all dissolved, it's all uniform. Chocolate milk, okay? You're not talking about all that leftover chocolate at the bottom of the container. You're assuming it all dissolves. That's very important. The parts do not settle upon stirring. Upon stirring. We'll just say they do not settle out. Okay? So if you go to the creek and you get a cup of mud water, it may look homogeneous at first, but if you let it sit, the mud is more dense and it will settle to the bottom. That's not what we're talking about, okay? Solutions, that doesn't happen. If you let them sit, they don't look any different than when you originally had stirred them and made the solution. So the particles do not settle out. In a solution, the particles are too small to see. The solute particles. Okay? And solutions may be colored or not. Like Kool-Aid is colored, right? You could have grape Kool-Aid or cherry Kool-Aid. It could be colored, or it could not be, like salt water.
You're way too close.
They don't have to be colored to be a solution, but they do allow light to pass. They are transparent. Whether they're colored or not, they are transparent. They do allow light to pass. Okay, I think that's it for today's video, just to give you a little introduction on solutions. Don't forget to do your reading on solutions packet. It will be turned in on Monday, so make sure you get that in. And enjoy the rest of your weekend, everybody. Bye-bye.